Hi, I'm Erica. I got an A star in A-level geography when I took it. I'm an experienced geography tutor and now I work for Geography Explained. So in this video today, I am going to be looking at the stores of carbon. Now this follows on from my previous video that gave a little introduction to carbon. It's quite a short video, but it should be immediately preceding this. I would say watch that video if you haven't watched this one. But essentially, as usual, what I'll do is go through the specification, where this comes from. I'll then go through some key 20 marker questions that you could potentially get asked on this topic. Slightly similarly to the beginning of the water cycle and to what I said in the previous video, is we're still early on in the topic. Some of the more evaluative or slightly more meaty topics come in as we go through the module, so I wouldn't say anything today particularly on its own lends to that much evaluative potential. There's maybe one or two questions that could possibly come up, but largely I would say focus your energy on really getting to know the grips of the knowledge, that AO1 that I'm going to be imparting today, and as you move through the chapter, more things will build up and you'll be more prepared to answer a much greater range of those 20 markers. And anyway, most importantly of all, the content today is going to cover of course the global stores of carbon. We'll look at some key terms, we'll have a little think about then, as we did with the water cycle, about the different spheres and how carbon is stored within them. And that is literally it. That is the whole structure of the video. So it's really very simple today. So just get a notebook out, get whatever you need to do, make some notes, maybe annotate your carbon cycle diagram if you feel like that is going to be helpful for you, but otherwise I would say let's crack on. If you find these notes that you can see on your screen helpful, then head over to the Geography Explained website, where we have many more notes to help you, particularly for the water and carbon cycles and many other different topics. We are also going to be adding lots of provision for revision webinars in the future, and we also have a place to sign up for tutoring. The main thing I would point you towards if you're struggling with exam technique is our 20 marker exemplar essay plans. I would definitely have a little look at those if you need some more ideas about how to structure your essays and you want some real world examples of very high quality, high achieving answers. So a 20 marker that you could get asked on this topic is potentially something like, assess the relative importance of different stores of carbon to the global carbon cycle as a system. This is because the specification here is literally global distribution and size of major stores of carbon, so the lithosphere, hydrosphere, cryosphere, biosphere and atmosphere. Essentially, it's quite hard to say how important one or other of the stores are. They're all important in their own different ways, but there are some arguments to be made, I suppose, about the relative importance of some of them, and you can weigh things up like residence times and sizes of the stores. So just start to have a little think about that as we go through, and we'll potentially revisit that at the end. Just think about how we can make that the best answer possible. But I believe that example is worked through and again available on our website. So when we think about the global stores of carbon, we think about it in a similar way, as I was saying, to how we think about the water cycle. So we need to know about how this carbon is stored and moves in between the lithosphere, the hydrosphere, the cryosphere, the biosphere and the atmosphere. Hopefully you can remember what all of those different spheres are. If not, we'll go through them as we continue on with the video. A key term that is going to be really helpful to know here, differs slightly from terminology we might have needed to know for the water cycle, is this thing GTC. So it stands for gigatons of carbon. Essentially 1 gigaton is equal to 1 billion tons. It's just a slightly easier way of saying it. Geographers basically use it because carbon stores are so enormous, they're so big, using things like tons or kilograms would be a little bit impractical. Similar way to people using something like hectares or something else like that, sort of aggregate measure. GTC is a really easy way for scientists or geographers to basically compare the size of different carbon stores as well. So let's start off with the lithosphere. So reminding ourselves of the definition that we came across in the water cycle, the lithosphere is the crust and upper mantle comprising this outermost solid layer of the earth. So not that sort of molten area of the mantle. So the lithosphere is definitely by far the largest store of carbon. So you could make an argument there that it's the most important, but that's for you to decide. So organic carbon can be found in things like soils and leaf litter, and also things like fossil fuel deposits of coal, oil and gas, but inorganic carbon is going to include your carbonate rocks, including things like limestone. So in our fact file, to put a number to just how big that store is, over 99.9% of carbon on Earth is stored in the lithosphere, so that's absolutely mega. Sedimentary rocks on land and beneath the sea store up to 100 million GTC, which is again absolutely huge. Limestone and chalk are basically carbonate rocks formed from marine organisms. I think I went over that beforehand. Their carbon can basically remain locked away for millions and millions of years unless it is released by something like weathering or tectonic activity. A little info box here as well talks a bit about that formation of sedimentary rock. Again, we'll go into it in much more detail when we talk about the slow carbon cycle in particular, but for now what you need to know is it is rock formed from layers of sediment that basically build up over time, often on the seafloor, and it can be formed in two main ways essentially. Mud containing organic material can basically be compressed and hardened over millions of years, or this calcium carbonate from the shells and skeletons of marine organisms can build up on the seafloor and over time start to form some of those carbon-rich rocks, including limestone. And now for the hydrosphere. So the hydrosphere, if we are confused again, is that portion of the Earth's surface layers that contain water, including ice, groundwater, lakes and rivers, oceans, and water vapor, and droplets in the atmosphere. So it's the water area basically. I would say again, any of these definitions in blue definitely learn because they're part of the AQA checklist. But you might not always associate the oceans and sort of water with carbon storage, but they're actually very significant. So oceans are a really big carbon store, in fact the largest in the hydrosphere, and they play this really key role in regulating atmospheric carbon dioxide as a result, because they're a carbon sink, which basically means that they absorb more than they give out. And basically carbon tends to be stored here as dissolved inorganic carbon that comes from the atmosphere. We've got small amounts as well living in living organisms, but I suppose you could probably attribute that more to the biosphere. Different amounts as well are going to be stored according to the layer of the ocean that we're talking about. So we might have less at that surface level, that's known as the euphotic zone, than those intermediate, also known as twilight areas, and the very, very deepest depths as well. So we've got inland waters as well, including your lakes, your streams, your rivers, all of that jazz. They store some carbon, so it's actually your non-flowing water bodies such as lakes, especially those filled with fresh water, that sequester, which means capturing and storing more carbon. And that's generally thought to be because of things like less turbulence in the water, releasing less carbon because less of the water is able to mix with the air, essentially, for that exchange there. So a good example here would be talking about the Southern Ocean. It's really, really important, even in relation to other oceans, because it really absorbs such a huge amount of carbon dioxide relatively. It's estimated to take in up to 40% of human generated carbon dioxide from the world. And that's basically due to very unique circulation patterns, cold waters and marine organisms. So when you study Antarctica for your compulsory human module, that is one of the reasons why that Southern Ocean is so important to be protected, basically. And watch out as well there for a potential synoptic question. I imagine that that's a very popular one for them to try and ask. Right, so now we come on to the biosphere. This was not explicitly covered in the water cycle topic. It does exist there, but you might be familiar with it from other forms, from other subjects, and it's just a little bit more relevant to the carbon cycle. It is essentially the sum of all living organisms and defined by AQA as the part of the Earth's outer sphere where life exists, including the hydrosphere and upper lithosphere, and extending into the atmosphere. So you can see it's kind of unique because it interacts and is made up of other spheres, which basically means that living creatures that come from oceans, for example, are actually also belonging to the biosphere. So you can see it's not that clear cut, but just in case the sort of theoretical frame of a question asks you to deal with the biosphere on its own, now you know. Vegetation then is a really important component, of course, of the biosphere. Plants remove carbon dioxide from the atmosphere through photosynthesis, and they store it in their biomass, so that's their plant tissue essentially, everything including plant stems, their leaves, and also their roots. Fact file then, around 19% of terrestrial biospheric carbon is stored in living vegetation, and forests store roughly half of all vegetation carbon globally, so that's why forests are so important there. So plant litter then, that's also really important. That is that freshly fallen organic material. So we're really thinking of things like those autumn leaves, or leaves that can fall off at any other time of the year, twigs, berries as well. It's a really key input into soil carbon stores, but basically types of litter and amount of carbon transferred basically depends, of course, on the surrounding environment and basically what the dominant vegetation is. So you might have sort of come across this a roundabout way if you've ever put compost in your garden, or one of your parents has perhaps. It's added to improve soil quality and plant growth, because the idea is that this compost contains so much organic carbon, as does this sort of plant litter, that the nutrients basically help plants grow. So it's maybe an important link for you there. But when we think of an example, it might be temperate deciduous woodland. So generally the type of woodland that tends to dominate the UK. We might see trees such as oak and beech shedding their leaves in the autumn as daylight and temperatures fall basically, and that transfers really large amount of carbon from the vegetation store to the soil surface. So you might, if leaves aren't swept away, I guess, so not so much in cities and urban areas, but you'll see this in more naturally occurring environments, more untouched rural landscapes and forests. But that litter is basically going to be decomposed by microorganisms known as detrivores, and that then also contributes to something called soil organic carbon and links the biosphere to something called the pedosphere in the fast carbon cycle, which we will also come on to. Animals also play a role in the biosphere. So in the grand scheme of things, they're actually quite temporary carbon stores. By the way, animals include humans, but they do play quite a key role in transferring carbon. This is due to the existence of food webs, so you know a little bit about how food webs go up in terms of size and predators and things like that. You've got your prey and predators, and you know, it links vegetation stores to those apex predators and things like that. There's also respiration as well, which links us to the atmospheric store quite nicely, and excretion. So poo is a bit of a transfer of organic carbon to soils and sediments, more so animals, but yeah, and then it's essentially decomposed and incorporated into some of those longer term stores. But that's partly what makes up fossil fuels and things like that, so maybe keep that in mind. Examples, whales, really important in the carbon cycle, again links quite topically into your Antarctica case study in the Global Systems and Governance module. They're really uniquely significant actually, because they have really large body size and really long lifespans relative to other animals, which basically allows them to accumulate and really retain carbon for quite a lot of decades. So when they die and sink to the ocean floor in whale falls, much of this is basically transferred into those deep sea sediments, and sort of it means it's removed from that faster carbon cycle and stored for a much longer time. So now we come on to the pedosphere, and you might have been a little bit more familiar with all of the other stores compared to this one. It's a little less known, so it might be a bit of a new concept, but it's basically referring specifically to that soil layer of Earth. That is where the lithosphere, biosphere, atmosphere and hydrosphere interact. So it's a little bit similar to the biosphere in that we've got this kind of intersecting area, but that's the main thing you need to know. It's just a different way of categorizing. Soil carbon, of course, can be either organic or inorganic as well, but two types of soils that are really helpful to know about, and that is going to be humus, which forms as plant litter. So thinking back to that biosphere section of the fresh fallen matter, including plants and leaves that decompose and become mixed into the soil. It's really thick and almost black in colour, and eventually becomes spread into the rest of the soil, so the most carbon rich there. We've got some pictures down below for you to compare. And then we also have peat, and peat is formed where waterlogged or low oxygen conditions basically slow that decomposition down, and it's found in those specific conditions, including things like heathlands, wetlands, and it tends to be due to saturation and because of that low oxygen being able to get in, which therefore creates anaerobic conditions, which again you might have learned about in biology, chemistry or something like that. So no oxygen, and that means that the plant litter is able to decompose so much more slowly and store essentially more carbon. So it's very important. Also comes up actually in various case studies in the River X one. If you're doing that, we certainly are. We talk about that, even though it's more of a water cycle case study, so you might already know a little bit. So those aren't the two only types of soil by any stretch, but they're just two really important types that you might want to use as an example at some point. And we come on to the fact file. So the pedosphere contains around 0.0031% of the Earth's carbon. So it does make it around 3 times larger than the atmospheric carbon stores, and second only to the hydrospheric stores, which is quite interesting because that seems like such a small number in comparison, but it still comes second. Peatland's really significant. They cover 3% of lands worldwide, so that's why they're so important. It's such a unique feature in the carbon cycle. Around 69% of forest carbon is actually thought to be stored in soils, which is wild. In the UK then, we've got lots and lots of peatlands. We've got 3 sort of main habitat types where you might see them: lowland raised bogs, blanket bogs, and also fens. So it's a fun fact for you. I don't think you need to know that, but now you do. One thing that might be more helpful is knowing that UK peatlands store around 3.2 billion tonnes of carbon. So it is a very important natural carbon store here in the UK. Then finally we come onto the atmosphere. So to refresh, if you're not quite sure what the atmosphere is, I mean, I say that sort of laughingly, but actually it is quite a specific definition, so make sure you get this one right. The mixture of gases that surround the Earth whose main constituents are nitrogen and oxygen, so probably worth knowing that, especially the nitrogen and oxygen part. Like, it's not just some random subsection of the sky, you've got to be a bit more exact about it. So we also, in the atmosphere, contain trace amounts of compound gases, including carbon dioxide and methane, which obviously become very relevant here. So concentrations of atmospheric carbon used to be much, much higher, but they sunk after glaciation periods, so like ice ages. Although these gases make up only a very, very small proportion of the atmosphere, they are still really, really important, as we know. Something to note is that being a trace gas means it is a small carbon store, not that it is necessarily uninfluential. So again, maybe something to think about for those more evaluative 20 markers. Carbon dioxide and methane are both greenhouse gases that play a really major role in regulating the Earth's temperature by trapping heat, and we'll go into this in loads of detail if you're not quite secure in that concept. You'll basically already know that increasing global warming and greenhouse gas presence is a direct result of anthropogenic, so human activity. So a little fact file is that the atmosphere stores around 720 to 800 gigatons of carbon, ever so slightly more than the biospheric store, and accounts for about 0.0017% of the Earth's carbon. So just thinking about how we measure these, for example, there's the Mauna Loa Observatory in Hawaii, which has basically taken measurements there since 1958. Nice little bit of history. And this is what basically provided the evidence for that increase in atmospheric carbon that the Earth has really seen since industrialization. And if you want to be really impressive, you can refer to that trend as the Keeling curve, because it is named after the scientist who basically originally monitored those initial readings during his lifetime and was basically able to make that causal link, and then started bringing global awareness to that increase. So in this section we have basically seen how carbon is stored in the different spheres of the Earth system. So Just gonna think about these in relation to the fast and slow carbon cycle very explicitly, just to clear up anything. So the main stores in the fast carbon cycle are the atmosphere, vegetation, soils, and surface ocean. So in the atmosphere, carbon is mainly stored as carbon dioxide and methane, and it's relatively small but really directly influences climate. Vegetation, so carbon is stored as that organic matter in plants, trees, animals, humans, and other living organisms, including phytoplankton, which means it's a short-term store and can change quite rapidly with seasons, growth, or any basically type of disturbance to that. Soils store carbon as dead organic material. They store it in humus and in decomposing biomass as well, which really links very closely with vegetation. And then the surface ocean, and don't worry, we'll go into the ocean in a little bit more detail. I realise we haven't studied it explicitly in detail yet, but it's coming up. But carbon is stored as dissolved CO2 and organic carbon in plankton as well, which will also come up. And the store also interacts very quickly with the atmosphere, especially when we're thinking of those upper layers of the ocean. And then in terms of the slow carbon cycle, then we have our sedimentary rocks, so carbon stored as calcium carbonate in rocks including limestone and chalk, and these form major long-term carbon reservoirs. Our fossil fuels, so coal, oil, and natural gas, store carbon that basically originated from organic matter and then is buried and altered over geological time, and this principle will be repeated over and over again in this topic. Deep ocean sediments as well then, so carbon accumulated on the ocean floor as shells, skeletons, and organic material before becoming rock, so very similar. And then the mantle as well, so you've got that subducted carbon containing rock, which might store carbon deep within the earth before it is eventually recycled. So that is the end of the stores topic. It's a little less long than the equivalent video for the water cycle, but by no means less important. But just to link back to that 20 marker that we spoke about at the beginning, so assess the relative importance of different stores of carbon to the global carbon cycle as a system. So remember, we spoke about the hydrosphere being the absolute biggest store of carbon. So there's a big argument to be made there that it's certainly the most important. However, you could definitely counteract with something like, oh, well, actually, even though the atmosphere contains almost these trace amounts of gas, carbon containing compounds, they are what basically mediates the greenhouse effect or the enhanced greenhouse effect, and so it's much more important, and you'll be able to back that up with much more detailed evidence the further you get through this topic. So don't worry about it too much, but you can sort of see where some of these arguments start to weave in at this point. Make sure to like and subscribe to our channel. Leave any questions in the comments box down below, and one of our team will try and get back to you as quickly as possible. If you need any extra help, make sure to head over to the Geography Explained website, where all of our fantastic resources are available, and as well try and keep up with us on our TikTok channels, our Instagram page, and wherever else we are on social media, as we're trying to push out as much content as possible for free to try and help you guys. And as well, we have loads of other free content on our website as well. It's not just paid resources. So head on over there now, and I will see you in the next video. Thank you. Goodbye.